This is a quick video on vector proofs. So I've got a really simple proof here. We've got a triangle. It's any kind of triangle, scaling triangle. I want to prove that the midpoints of the sides AB and AC respectively, if we join those two up, then that vector from M to M is parallel to B to C. This is it's pretty simple, but we need to know how to do these kind of vector proofs, starting with an easy one. So let's go. How do we get the vector from M to N? All right, let's get an expression for that thing there. Well, to go from M to N, we need to go from M to A first, and then from A to N. Okay, so that's the way I'd go from M to N. So let's write that down. M to N is the vector M to A, and then we're going to add on the vector A to N. Okay, now we're given certain vectors up here, and these are the ones that we're going to use to do this proof. We know the fact that AB is the vector A and AC is the vector C. Alright, so M to A. Well, if A to B, if this whole line along here is A, then A to M will be a half of A. So M to A will be negative a half of the vector A. Similarly, A to N is a halfway along A to C. And A to C is just C, so this is just a half C. So I could write that out like this if I wanted to. This is quite nice. There we go. Alright, so now we just need to know, well, what's the vector from B to C? If we look at a similar B to C, well, B to A first of all, and then A to C. That's how I'm going to get from B to C. So I'll write that down. B to C is B to A plus A to C. If we know A to B is A, then B to A must be negative A. And A to C, we know that one. A to C up the top there is just C. Or we could write that as C minus A. Okay, so now we've got this, and now we've got that. We've done it. We've shown really clearly, let's go for the nice purple, we've shown really clearly that M to N is a half of B to C. So that means if that vector is half of that vector, we can therefore say that the vectors are parallel. And not only that, because we have this number here, we can also say that the vector M to N is half the length of the vector from B to C. So if you look at the diagram there, that's exactly what we've got going on. Pretty simple, but those kind of ideas you'll use in all of these vector proofs that you have to do.